You're about to have one of the most exciting adventures in the universe, a visit to another planet. On today's trip to Mars, you'll see the red planet's rugged beauty firsthand and encounter one of its early robotic explorers.
The ship is ready for launch, Commander.
Thank you, Pilot. LV, EOS is go.
Confirm EOS. Your go for main engine start. 3, 2, 1. Lift off.
We'll be getting clearance from the Lunar Gateway on our way out. The Gateway was our first real step towards deep space exploration. It serves as a staging ground for missions to the Moon's surface and to Mars. Lunar Gateway, this is EOS. Contact EOS. You are cleared for Mars. Course laid in for our planetary neighbor. In the early days of the rover program, this journey used to take about 7 months. Welcome to Mars. The dusty red planet we know today didn't always look this way. A couple billion years ago, Mars was mostly covered in water. The mystery of what happened to Mars water is a big part of what the researchers at the Mars Outpost are studying. If we can understand what caused Mars climate change, we might be able to better care for our own planet. That big gouge in the surface is a canyon called Valles Marineris. It's about 5 times as long and 4 times as deep as Earth's Grand Canyon. We're coming up on Olympus Mons, the largest volcano in the solar system. It stands 3 times higher than Mount Everest and is roughly the size of the state of Arizona. Martian Outpost, this is EOS. Contact EOS. You are cleared for approach. Today we'll be visiting one of Mars' pioneer explorers. The Perseverance rover arrived at the planet in the year 2021. Before we had people at the outpost searching for Martian life, rovers were a primary tool to study the planet. They have ranged boldly through this alien landscape to test new technologies and uncover evidence of Mars' warm, wet past, including minerals formed in ancient water and the chemicals necessary to support living microbes. Perseverance's mission was to seek signs of ancient life and collect rock and soil samples to be returned to Earth for study. It also arrived with the Ingenuity helicopter, the first test of powered flight on another planet. With each successful test and discovery, Perseverance and Ingenuity brought us closer to getting boots on Martian soil.
Commander, a dust storm appears to be forming over the crater.
Visibility's dropping. We're going to stay low to avoid any damage to our heat shield. Martian dust storms pose a real problem for equipment like solar panels. A planet-wide storm caused the demise of the Steadfast Opportunity rover back in 2018. But now, it's time to make the journey back home. To a world still lush with water and life.
EOS Mission Control, welcome back. Your approach is free on arriving traffic. Clear for landing on LC-73.
EOS copy.
One disengagement for flight position.
EOS holding. From the time humanity first spied that fiery orb trekking across the heavens, we've been fascinated by our red neighbor. Whether we're exploring remotely via rovers or in person at the outpost, the exploration of Mars is full of exciting possibilities.
Exoplanet Survey Satellite, or TESS, launched in 2018. Its mission is to search out new systems of exoplanets around distant stars. The universe is full of uncharted worlds. Even our own solar system still has mysteries to be explored, like if there's a massive ninth planet somewhere far beyond Neptune. But here's our course, 40 light years away towards the constellation Aquarius. This is TRAPPIST-1. Found to host 3 planets in 2016 and 4 more in 2017. Astronomers were excited by this discovery because TRAPPIST-1 has at least 3 Earth-sized planets inside its habitable or Goldilocks zone, the region around the star where it's not too hot or too cold for liquid water to exist on a planet's surface. Astronomers are always looking for terrestrial planets inside the zone because they're the most likely to support life as we know it. Of course, habitable and livable aren't the same thing. TRAPPIST-1G is just inside the system's cooler edge of the habitable zone and has a global mean surface temperature of -100 degrees Fahrenheit, so not quite as cozy as Earth. As a red dwarf, the star TRAPPIST-1 also has some interesting differences from our own yellow dwarf home star. It's up to twice as old as our sun, but only about 1/8 our sun's size. This means all its planets orbit very close together. The orbits of all 7 planets would easily fit inside the orbit of the closest planet to our sun, Mercury. TRAPPIST-1F is only slightly closer to the system's star, but thanks to its dense Venus-like atmosphere, it's much warmer, over 500 degrees warmer in fact. So it's also unlikely to host life as we know it, which leaves remarkably Earth-like TRAPPIST-1E on the warmer edge of the habitable zone. I'm going to take us in closer. Everyone hang on, the orbital debris always makes this entrance a little tricky. Habitability is a delicate balance, but when it's achieved, it's pretty spectacular. When planetary makeup, surface temperature, and atmosphere all interact together just so, they create the conditions necessary to support life as we know it. And with more planets than stars in our galaxy, Earth-like worlds certainly number in the billions. Now let's travel 40 light years back to our solar system for one more planet you just have to see. With countless planets in the Milky Way, it's pretty incredible we get to call this one home.
TESS Mission Control. Good to see you. Your approach is free for riding traffic. Cleared for landing on runway 31.
Helios, copy. Helios holding. You'll be transported back to the gate shortly. It's been a pleasure having you all aboard today. TRAPPIST-1 is only the beginning. There's a whole universe of uncharted planets out there waiting to be discovered. And we'll never stop exploring.